Stephanie, thank you so much. It's great to be here at the Wild Center. As Stephanie said, the Wild Center has always been very supportive of green building, and I've always really enjoyed this conference, and it's really a pleasure. It's a pleasure to be here, and it's interesting. Larry Master is a LEED Platinum house in Lake Placid, and net zero energy, and a lot of what I learned on that house went to this project, which is, it's very similar and very different. The scale is immensely different, and that's what's both exciting, challenging, interesting, all those things. So let me just tell you a little bit about myself. I grew up in the Adirondacks, Saranac Lake, and I went to undergrad, I went to school for forestry and earth science. Grew up here, love the woods, love the area, as I'm sure most of you can relate to, and did carpentry for 5 years after college just because I liked being outside and it was fun. And then I was, with my environmental background, just got into, I always saw the blend of environmentalism or green, being green on whatever level, and construction. And those passions convinced me to go to architecture school, and I went to the University of Oregon for architecture school. Came back and started my business 6 years ago now. And Larry Master was one of the my brother did a project. Larry Master was one of my second clients, and we're 6 years in. And I'm just going to tell you about one project. The Black Mountain Design Build is my company. We're based in Saranac Lake. I'm a licensed architect. On this project, I'm a consultant. I was not the architect on this project. And 80% of our work is in this region, very close to Saranac Lake, Tupper Lake, the Tri-Lakes region. 20%, I'd say, is consulting outside the area, and that's what this project is. Just give me 1 second here. So, this is what we're going to go over for the next hour. I want to save time for questions at the end, and to me, this stuff is really exciting. I'm going to go into a lot of detail. I'll try to, if you miss something, just ask at the end, or we can flip back slides, but I'm excited about this project, and I want to just share as much as I can with you. I want to further this industry. I want everyone to be able to do this stuff. Some of it's cutting edge, but it's just you learn as you go. You experience more. Every project you learn more. So we're going to go through some definitions, project goals, overview of the project. What is it? What did we do? The project team, and the design process. Who did it, and how did we get this? You can't just show up and do this. You need a really solid team. We'll talk about that. Building systems is the nuts and bolts. That's going to be the building science of this is what the foundation was, this is what the wall was, this is what the roof was, all that kind of stuff. And we'll get some preliminary energy data talking about how we're doing, and then we'll open it up to questions. So first of all, some of you likely know what these things are, but net zero simply is a building that produces at least as much energy as it consumes over a 12-month period. And that was one of the goals that we'll get to. Market rate, that's an important term, because what's net zero, we talked about doing it 6 years ago. We did a single family home and we did it net zero. Market rate, what that means is an apartment, which these are, rents for comparable to other apartments in the area. So if you decide to rent, if you're in Schenectady area right now and you want to find a 1-bedroom or 2-bedroom apartment, you can rent at Net Zero Village, or you can rent at another apartment, the new development that went up last year. And in Net Zero Village, all the utilities are included. You'll pay the same amount of money. So you're not paying a premium. Some people may choose to live there because it's a green project, but there's lots of people there that are just moving there because they'd rather live there than anywhere else, and it's market rate. Another term, and it's important, I'm not sure this is actually a term, but off the shelf, I think most people know what that is, but that's a really important term for this presentation, because in order to achieve it, we needed to use construction materials that are produced in mass quantities and readily available. It just drives the price down when you start getting off into specialized areas. things get more expensive, more complicated. So the first goal was from the developer, the client, who is David Bruns, Bruns Realty Group, and he wanted to demonstrate that market rate, net zero multifamily development, he wanted that it's commercially viable in the Northeast, so that you can do this and make money. So it's all good to be good for the environment. If we can make money being good for the environment, now we're really getting somewhere. And the team's goal was to create a successful and profitable development for the client, and also to develop a process that could be used on future projects and move forward, that this can be replicated. So, project overview. This consists, and I'll get to some pictures and very soon, but 13 12-unit buildings. So this is 156 apartments. And there's a clubhouse, exercise room, common spaces. I'll show you, there's 1 bedrooms, 2 bedrooms. And in terms of amenities, you have air conditioning, you have a dishwasher, you got washer dryer, there's carports, which actually is where we're producing all of our power, the PV. And when you rent here, you get your electric, you don't have an electric bill, your hot water, your heat, your air conditioning, your internet, none of those bills. You just move in for one price, and that's part of the package. And a lot of people like that, the simplicity of that situation. I would love that, personally. So Energy Star, it meets Indoor Air Plus. It has another thing architecturally. Again, I wasn't the architect on this. I worked with the architect Harris Sanders out of Albany, but they did a really great job. And it's 9-foot ceilings. You'll see the daylighting, and it relates to energy, but it's just that's another thing. And electric vehicle charging. So I set a different scale. That's the site boundary, and you can see the first 6 buildings in the top of the screen. And this is I-90, so a different drive than you all had today and I had today to get here. So you got to kind of reframe your thinking here, the scale, the region, and it's right where Interstate 88 meets I-90, so the road that goes to Binghamton and I-90 between, this is just west of Albany. This is the site plan. So the last slide I showed was these 6 buildings, and you can see these are the carports, and that's all covered with PV that we'll get to. So all these areas here are carports and PV, and that'll get involved with the net zero aspect. Leave this slide up for just a second. You can see that interchange. You can see where again, this is the first 6 buildings, and then this is 2 phases, and now the second phase is on the bottom of the screen, the first 3 buildings, then you can see 1 in the back. And what's interesting about this slide is, these buildings go one after another, and so it actually started here, went to here, and then there's a little lag, and we started here, and you can see this one has panels and siding, and this doesn't, and then this end is just a slab over here. So completely different scale, different approach than a single-family home. A few more pictures. This is later on in the project, and this is the whole thing. All the stormwater is on site here, due to DEC regulations. I'll get into more specifics, but you can start to pick out the solar thermal panels on the roof, the PV on the carports. You'll get into look at some of the shading. This is facing south. Another picture here, as I'm going to sort of zoom in here, I'm going to start high, and we're going to get into the apartments, and we're going to start talking about some of those features. But this, again, you can just start to see the character of the building development. So getting back to the market rate aspect, I'm not an expert in what it costs to rent in Schenectady, but this is off their website currently. So this is what it costs. And I have one more blow up of these rooms, but this is kind of, what you're providing for someone. This is a 3D rendering, and this way is south with the windows going this way. You have a living room, a bedroom, closet, washer dryer, sink, a peninsula kitchen, and a basic kitchen. So, and there, like I said, I'm not going to show you all the units, but there's 2 bedrooms, 1 bedrooms, different versions. But this is what we're doing for people at a mass scale. These are actual pictures once it's complete, and some things in one of these apartments you'll note is you'll see some pictures of the north side of the building. The kitchens are on the north side, and we have these small windows here which provide daylight, which is great, but they're small, and a lot of you understand the basic principles it will get into of facing south, getting heat from the sun from the south, blocking to the north, not having big openings. When you get in a bigger, one thing I've learned from this project, things change when you get all the dynamics change a little bit. Some of this stuff becomes less important, not at this scale, but I'll get to, we're working on a double loaded corridor version of something like this. When you get a little bit bigger buildings, and in commercial buildings, it's really about air conditioning versus heat. This doesn't hit that tipping point, but when you get a little bit bigger than this building, you start to get there. But this is a bedroom. You can see the sun coming in. I'm going to keep showing you, and you understand why. And it's just a nice, 9-foot ceilings, and you can see this is what we're ending up with. And I think this is a really important point because could you picture yourself living here? Because this is what's net zero about this? I mean, I could point to a couple features, but it doesn't look net zero. There's not necessarily, that's not the point. The point is that is the rate that we're doing it. So the project team, the reason I have this slide is there's a lot of people, and they all have to work together, and this is not a simple thing to do, and it's not a simple thing to coordinate. And I'm not going to go through all the lists, but every single person here is vital to being engaged and communicating with all the other peoples and at the right time. So there's a reason why this isn't done more often, and you need a really good team, you need a really good client, you need a really good architect, you need a really good builder, and by really good I mean open to learn and open to communicating. So the design process, one thing to do a project like this, some more traditional architecture ways of building, and this is more in the commercial than residential, but you'll design everything. As the architect or the consultant, you're the holder of the knowledge, and you put all your wisdom onto the page, and then you put it out to bid, and whoever has the lowest price gets the job as a contractor. We could have never done this. This project never would have happened that way. So rather than have an attitude of, and again, not that there's this attitude, I'm not being critical, this works really well in other situations, and it's an industry standard, there's nothing wrong with it inherently, but in 2016, to do a project this way, we couldn't do it that way. So maybe in the future, that'll change. But what we do is you have to front load the information. You can't design the building and then hand it off to the the structural engineer, and then they hand it off to the mechanical person and the electrical person. All those people when you have the napkin at the beginning, everybody kind of has to be looking at the napkin, and then you have a footprint and kind of an idea of a building, and everyone kind of weighs in. Hey, where am I going to put my solar panels if you do that? Where am I, the civil engineer? There's not enough room on the site. The solar thermal installer, if I put it on the roof, the trusses need to be stronger, and then the structural engineer. So but all that stuff has to be thought through really early on, and that's a different design process. Another key part, this document here, so Green Hammer, when I went to Oregon for architecture school, I worked afterwards for an architecture, design, construction consulting firm called Green Hammer, and I stay in close touch with my friends out there, and they run passive house analysis on passive house projects, which is in the industry, the most, rigorous, innovative type. If you're looking at an energy efficient building, that's the top of the pyramid right now. And so although we weren't going for passive house, and that wasn't the goal, we used the passive house modeling software to analyze all the pieces that went into this building, because with enough money you can make something happen, but the trick here was we can't charge more rent, and this has to be successful. So that's the essence of what was really cool about this project. So the client came to me and he said, we were talking about using closed cell spray foam in the walls, and again, we could have a whole hour lecture on that, but he said, should I put 2 inches in or 3 inches? And that's what was fun, and that was to me, and I was like, this is going to be a fun job. I'm like, I don't know. That's a good question. How do we figure that out? He's like, well, should I buy a solar panel, or should I put 2 inches of foam? Should I put 3 inches of foam? And of course, the contractor's role is like, can we do no foam? Like, I want to get this to be not expensive. And of course, I'm being facetious, but that really is his role at the table, is like, do we have to do this? And at the end, it becomes a balancing act of what you want to manage the risk for the client. You want to use your building science knowledge to understand when they're doing something that's expensive or you can't cut because it's vital to the success of the system. So what we did in this is, this is an Excel spreadsheet output, but we went through like, well, I'll do this, good, better, best. And don't strain your eyes on this, but you can see every aspect of the building. We've honed this now for a round 2, but every aspect of the building, you see kilowatts. So for the walls, from this wall assembly, we determined we're going to have to provide 34,000 kilowatt hours. If we go to this one, 25,000 down the line, and then the contractor can price this for this and say, well, I can buy solar panels at this price. I'd rather buy a solar panel. So that was the real light bulb of this project of how to do this market rate. We had to use real information to make informed decisions. So again, Windows is one example. Going from this one to this one, you have 10,000 kilowatt hour gain. Going to here, you only have, the incremental savings gets less and less, and you fit the price point that makes it, and then we look at all the other issues that go into a building. So jumping into the building systems here, these are all the things that I'm going to talk about next that go into how do we do it. The envelope, which is the insulation, the solar, the heat gain, the heating system, the ventilation system, the hot water system, and then the appliances and the monitoring. So I'm going to leave this slide up for just a minute. This is the north side of the building. You can see those kitchen windows for each of these apartments. And you notice the zip system. You've probably all seen this if you haven't used it around. It's what's nice. The reason we used it on this project, and again, there's no good product or bad product. There's when do you apply it. Air tightness was going to be a huge metric if I went back to the Green Hammer report on success for this project on multiple levels. What was good about this is it was green and black, and you could walk around the building and see if it was done. Like and the colors didn't matter. but really, like that, and the other thing about doing this market rate is, as an architect, designer, I get plenty complicated details, and on a higher end project, you can have there's reasons to do it, and you can get it done. On this project, we didn't want to, if you start scaring the framing subcontractor, the insulate, and it looks really different. It's not that it can't be done. On a high-end residential house, that can be done. But on this scale, we had them to bid, the subcontractors bid to the GC in terms of the construction costs. They needed to look at it and say, yeah, I've done 2x6 stud walls. That's what we do all the time. We don't put an inch of this foam plywood system on the outside, but I know how long it takes to put up a piece of plywood, and it's just a different piece of plywood. Not a big deal. So that's the approach we had to go through the whole building. That gets into the off-the-shelf aspects of things. Another thing to note on this, all right, laser. Notice this detail up here. I'm gonna get back to this. And this building was extremely airtight, but you'll see some stuff with this detail at the roof. This, again, this architectural drawing, it's long on the east-west axis. You look at the difference in the glazing from the south side to the north side. And again, just this wall assembly detail. And you can see we're not doing it. This is a code building, actually. And that's where the economy of scale of the volume. We're using in the wall the zip system, which is an inch of polyiso, and it has a thermal break for all the studs, and then we're putting closed cell foam in the wall. Under the slab, We have 2 inches of XPS, which is a foam that most houses have underneath their basement slab. In the roof, we have 4 inches of rigid polyiso board, which is what every box store probably has on it that any of us have ever been into. And then we can get into nuances of those wall assemblies, but we were meeting code. Code is changing, but we weren't doing anything really crazy with complicated, thick wall assemblies or any assemblies. So again, the air tightness, blower door, and we could talk more about that. And you can see here, I love this shot because we'll get into the glazing, but you just see the sun coming in and heating this space during construction. And that's a mechanical system. I mean, that's an intentional mechanical system in the summer, and then we have to shade it in the winter. And then I'll get to that. We need to shade it in the summer, or else it's going to be way too hot in the space. This is the 2 inches of foam underneath the slab. And again, now the walls are up, and you can see that mechanical system coming in. And to do that, to have that work, we need that glass has to be specified in a specific way. This describes the winter sun and the summer sun. And in a house like this, you often have an eave or an overhang. You'll see some pictures in a bit where we have some shading that gets into that a little more clearly. And also this device here, it's called a solar pathfinder. And this is a great tool. I often joke because it's expensive. It's like a couple $100s or something, and it's like feels like kind of cheap plastic. But one way or another, you stand over the thing and you look in, and it just shows you if there's a pine tree by the corner of your house and you're wondering if it's going to block your solar panel or your deck or anything else. You look in and it shows you all that stuff. So that's real. So understanding the site, both on the site level, the civil engineer who's laying this stuff out, they're not used to worrying about whether stuff's in the shade or not, and how close they put the buildings to the next property, and if the property line is east, west, north, or south. So this picture I love because it shows what we did is we put these shades over the windows, and this is if this was in my photos instead of here, I could tell you what time and whatever. But obviously it's in the summer and it's around noon, and it's preventing. So we have glass on this building that lets the heat in, but it's not letting it in right now. And when we modeled in Green Hammer the report that we did, you could see if you didn't have these on, you'd see the AC load go up like this, and you say, well, we got to buy that many more solar panels to. And like, we don't want, the contractor's trying to keep us on budget. I don't want to buy solar panels. I don't want to buy he didn't want to buy anything. So anyway, I'm joking. I did, But anyway, it's a fun. We all do our jobs, but we have fun doing it together. Another thing I'll just point out is I think this is a really nice looking building, but there's green building. You pick your different things. This has this is vinyl siding. We could have a whole, we could talk about vinyl siding. We could talk about all the other things, but as much as I'm an idealist, I'm a realist. And again, there's lots of topics that could be their own seminar here. Okay, so this gets to what I was just referring to, and this is amazing, and this is where data and doing data at this level really blows your mind. So in terms of kilowatt hours, we're getting 19,000 kilowatt hours is, in this climate, in the model, predicted to that much energy is coming through those windows based on the glass we chose that's letting the heat in. Up here, so the heating system, we need to produce 42,000 kilowatt hours, so more than double, but with the COP, which again, I'm not going to get too into, but the efficiency of the electric heat pump that we're using, we're predicting in this building that we're putting in 17,000 through the electricity to heat it, and we're getting 19 from the sun. So it's just, I would have expected that, but it's great. We'll take it. And the way we do that, this is a ductless mini split. We'll get into some of the appliances, but you can see that's what's heating every apartment. And again, it works down to 15 below. We have electric resistance. We're providing fresh air, which is an upcoming slide here. But again, it's an apartment. This is the back of the apartment. This is what a mini split looks like. If you know, every apartment got its very own single one. We looked at all sorts of options, but every apartment got Another side story that if we have time at the end, I'm happy to talk about any of this stuff in more detail. But budget-wise, you'd like a head in your bedroom, one in the bathroom, one in every room, right? The contractors like to keep on budget. I want one. So we ended up using a transfer fan to go from the living room, moving the air from the living room into the bedroom. And there's a lot of research. And this is where this gets really fun with a client like this, because I'm not saying, well, yeah, you can spend money and do this and this and this, and it's no problem. But I let them know when they're getting into, like, are you going to have occupant complaints where it's not warm enough in the bedroom? Well, this is help them manage those risks, and we did, and it's been great, no problems. But then you have to make those type of decisions when you're trying to, when you're on the cusp of doing something new. Ventilation. You have to do this in a tight building, and it all gets down to humidity, which that's a moisture meter. I don't know where it is. I lost it. If anyone sees it, let me know. I'll buy another one. But anyway, that's not the point of today. But yeah, you got to manage air, get fresh air in. You have to transfer if you're working to get all this energy, you have to transfer the heat so you're not wasting it going out. Humidity management, and you can filter the air. Getting better air quality than you would have in a traditional home. In order to another way we did this, and this was a nice sort of program that seems to be loose. Other people in this room probably know more than I do about it, but they were, at the time, they were incentivizing solar thermal. So right now, and this is working this way, 83% of the hot water that's used in this apartment is produced from these arrays on the roof. And Pete Skinner of E2G Solar designed it, installed it, and it's working great. It has an electric resistance backup. So 20% of the heat is in November. Obviously, in this thing, it's been unbelievable. So the next project Pete is doing is we're actually we're using less panels, like on the next project, because we're just like, well, yeah, we can make 83%, but what does the system cost? Let's just, now we're going to optimize it. Let's use 70%, have it produce 70%, and have save a lot of money, and then figure out how to do it better every time. PV. So every building on the carports has a 66 kW system, and which is larger than we need, which is a good thing. But I don't want to get to the end of the punch. That's my punchline at the end, is that we did it. So I'm not trying to punch it, but yeah, it's a big system. But the reason we did it is because we made the building. I wasn't, when they said how airtight, and the metric is air changes per hour. I don't know what code is exactly at for this building. Maybe it was 7 before, and now it's 4 air changes per hour. It has to meet code. So I said, I know we can do this building at 2. I've done houses that are well below 1. But we're running it through the trades. This isn't a custom home, high-end contractor. Money is the object. But we can do that. End of the day, and that's a huge lever. That's the biggest lever on any energy efficiency, is not having your windows open. If you have your windows open, who cares what kind of furnace you have or what kind of insulation you have in your walls? And if you don't have a building airtight, that's exactly what you're doing. So part of the reason that solar is relatively cheap, that's one thing, compared to a lot of other things when push came to shove. And also, because we got the building so much tighter than we were willing to bank on, we just ended up not needing as much solar as we needed. Now, you can't just buy solar. This is all funded through NYSERDA, the low-rise program, and they have thresholds through, with HERS rating. It has to be pre-PV 50, post-PV 10. I won't get into that, but you can't just solve everything by buying a lot of solar panels. Energy Star appliances, LED fixtures, but again, what we did is we just went through the Energy Star website and looked at all the Energy Star appliances, and we just picked ones that were off the shelf, nothing fancy, but we still picked the ones that use less energy, and put all those into the program. Each apartment gets monitored for energy, and I'm not going to get too much into the the whole monitoring system, but we did a lot of analysis that we're still processing. So I'm going to talk about construction administration, which is basically, that's what designers do when they're not building it. When someone else is building it, construction administration is what, and I do a lot of explaining this to people, and when you're doing a project in design or construction, especially when someone's doing a house for the first time, like this is a whole new world, it's all new language, we need to communicate it. But construction administration is, you can have this all great on paper, but then what happens when it actually gets built? And so this photo is, you can see the 2 blower doors. So there's 6 apartments on this. This is the entry for 6 apartments. This is the entry for 6 apartments. And we have 2 blower doors set up to test it. Now, this is a smoke test. Now, in full disclosure, this is after the test when I was trying to air the building out. And we only did this on the first building. But what this is theatrical fog. And we fill up the building with fog, and then pressurize it with a blower door. So we're not trying to figure out how airtight it is. It's like, at this point, there's no spray foam in this building. This is just, I wanted to test the building with the green and the black, and anyway, this is what it actually looked like, and that's the detail I was talking about later up there. So there's no stuff coming out of here. These windows were paradigm windows, single hung. I was really skeptical, like, more of a high-end residential, like casements, awnings, they close better, all this. We ended up with a really good quality vinyl window, and I've tested triple pane windows from Europe that who knows how much they cost, and I've seen smoke pouring out the corners. Not pouring, mind you, sorry, that's a little of an overstatement, but I've seen smoke coming out the corners. And nothing on these windows. And nothing here, but you see the membrane on the roof and here, and there's a gap. So from the inside, that's what the gap looks like. So eventually, you're going to spray foam your wall, and you're going to spray underneath the roof and this. But so the idea here is that you think spray foam, if you spray foam it, it's air tight. It's true. Incidentally, if you just spray foam a house, it does make it more airtight. If you're not paying attention to anything, it does have that effect. But the theory here is we're not depending, except for right here, on spray foam to be the airtightness. That's the other stuff. It's just you can put a bat in, you can put cellulose, you can put spray foam, whatever you want. But I've seen this over and over. When we get to the end, you'll see some airtightness. This is still the biggest leak in the building. It's very small, but this is all spray foamed. It looks all like nothing could ever go through it. I've seen this on several projects. Air goes around spray foam, but it only matters at this level when you're really getting to the fine grain. If you're not, in general, it does a great job. Can anyone see what's wrong with this picture? It's minor, but I just want to take a moment to turn it back on you. And it's sort of a minor thing, but well, that's true, and I tried really hard to get rid of that. No, well, okay, this is good. Wait, okay, so one at a time. What was the first question?
The first question is that you have
right. So I could get it without getting too fine grained. This is great, and we've thought about this. So that's what I thought I was going to talk about, but I want to talk about what you talked about. So I tried to get every stick of framing out of here, and again, this isn't a custom home, and I took this inner stud here out in this one, and it was like they did end nailing because it was like you didn't need to. It wasn't a big deal. This is not a custom home. It's getting run through the trades in Albany, mass produced, and the quality of the work. I mean, some of those sills were like you had to, it was like becoming a problem. Not like this. Again, I catch myself exaggerating, but enough that it wasn't acceptable tolerances. And so the contractor's like, listen, I got this, to get this on price, I need this framer to do it. This is the skill level of this framer. And if I don't have these in there, they don't cut to, that I can't, and you're doing, it's 156, it's just mass produced, going through. I can't get the job done. And then in terms of analyzing even some of this other load, we had 1 foot on center on the first floor on the north and south, and the top 2 floors in the east and west was 2 foot on center. So we did do some of that. And as I really pushed on this early, but it just got into, all right, let's just wrap the place with zip sheathing with some foam to break the thermal bridge, and that's going to be the best solution. And we did some analysis of what that, so best practice, obviously, yes, there's a lot of wood you could take out of this. Next question, before I get to the corner. Is there someone else? Thank you. Yeah, I don't know. That sounds, it looks bigger than it needs to be. So again, all of this comes down to what do we have time to care about? And I agree, like I don't want to waste anything, but there's lots of, the wood, yeah, I pushed on the wood and like, I had to push a lot on a lot of things, so I picked my battles, and
I mean, one thing you could do, actually do is joist, roof joist.
Yep.
It would eliminate a lot of lumber.
Yeah. No, you're right. So I'm gonna keep moving here and make sure it's time for questions and go get back to any of this. But no, so during construction like this, you can't. There's a void behind that. You can't get to that to insulate it. And again, is that going to sink the project? No. But if you do that 156 times and you do it on both sides, and not so much that, but also there could be you need to keep everything warm. There could be a dew point. It could be a condensation. As much as it's a using more energy. There's all sorts of things. So during construction, you walk around, you keep an eye on this stuff, and just make sure that everything is actually going to plan. Did they deliver the right windows that were called out? Did they show up with the right spray foam that was called out? You can call and say, did you foam around the windows? Yep. But then you go in here, and that's supposed to be filled, and I could see daylight, and it was, and again, this was on the, I don't know if it was building 1 or 2 or 3, but at a certain point, there's 13 buildings. At a certain I walked down, go down once a month, I saw this, and in time that they redid it, and again, they knew that for the next building, yeah, and we can't not do that properly. And it wasn't that someone was trying to get away with something, they just don't know they might not know how critical that is. The slab, again, you see the 2 inches of foam, and honestly, this isn't even normal. I didn't realize this. This is not even normal on commercial building to put 2 inches of foam under the slab. They don't bother. They just put some plastic down, and it's better to have insulation in the wall where it's up here, it's 20 below, than it is the ground's 40, 50. It's like it makes sense. But that's the type of stuff we had to do, and then continuous up to here, and up the walls. But this was an important aspect during construction. So this is in theory, how this project is going to perform. It's, and again, this was what came out of our report. And every month, and you can see the solar, obviously in the summer, you're producing more. You're using more in the winter. So that's the concept of net zero, is that over the year, this all balances out, and you're producing as much as you consume.
That whole building?
I believe this is one building, yes. We have, every apartment is metered, and the common areas are metered by utility meter. And then we have e-gauge for all apartments. But all that data, I'll get to how conclusively we are net zero and where things are at.
All those bills just go.
Right. So this is just an early thing. This is last year, the first couple months. But just looking at the first couple months, we're saying, this is what we predicted, and this is, high user, and this is where we are. So we're like, wow, yeah, this is really starting to, it's starting to track once we get the first couple months. Now, this isn't a full year. This isn't, multiple years, but it starts to show that we're getting some preliminary data that we were on track. This again, just it shows for that month. Yeah, look, it's kind of looking like it's net zero. It's this is we're producing what we predict more, and in a given month it seems to be in range. And so I can get you by August we'll have actual official. So Tatum Engineering out of Ithaca is hired by NYSERDA, there's a program to fully monitor and give feedback on this building. But all signs are looking positive. We're overproducing, and it's good to go. But we don't have the official data at this point. What I can tell you is it appears, and again, what it is, our predictions seem to be plus or minus 5% of what we predicted. So what we predicted for usage, based on nothing out of it, this passive house model and a good person who knows what they're doing with it, is we're right on top. I mean, that we know. We're predicting how much we were going to use. We are using very close to that amount. And then we know we have a very oversized PV system. So that's why we got to get the final word. It's not official. And again, it's not official. So I'm not saying that we did it, but I did say yes there because I'm pretty confident. But we'll know soon enough. In the next month or so, we're going to have results that are extrapolated for a year where we've had half the building is fully occupied, and then when they came online, you saw the construction. Like it's when the building got filled up, and you have to extrapolate because it wasn't truly filled up for a whole year. But by the end of the summer, we'll have all that data, and it's looking good. So, project overview: it's the first large-scale market rate net zero multifamily project in the country. And I keep saying this, and I couldn't find any precedents. I keep saying, if anyone knows anything, let me know. But it really, for everyone I've talked to, it hasn't been done, which is I'm really proud of. It's a really what we've been able to do through this team, and what I've described is new, and that feels really good. The building design was based on optimizing every piece of component. It's off-the-shelf materials. It was completed already, 2016. And the other thing is we're currently with the same team in schematic design with the next project, and it's still in Schenectady. Down the road, it's going to be 256 units, net zero, and we're applying all this information to the next one, and we're hoping to break ground at the end of this year, and we're currently on track to do that for phase one, which would be three 24-unit buildings. And that one it's similar to this, but it's a double-loaded corridor where half of it's facing north, and that's what I was alluding to earlier. So with that, if any